Hey. The topic I am going to discuss is Student's t-test. Student's t-test. It is a statistical test used to compare the means of two groups of data to determine whether they are significantly different from each other. The t-test is a parametric test, which means that it makes certain assumptions about the data, including that the data are normally distributed and that the variances of the two groups being compared are equal. If your data do not fit these assumptions, you can try a non-parametric alternative to the t-test, such as the Wilcoxon-signed rank test for data with unequal variances. Types of Student's t-tests. There are several types of t-tests. One-sample t-test. Paired t-test. Unpaired t-test, independent samples t-test. One-sample t-test. The one-sample t-test is used to compare the mean of a single sample to a known or hypothesized population mean. This test is useful when a researcher has a specific hypothesis about the mean of a population and wants to test this hypothesis using a sample of data. Steps in one-sample t-test. 1. State the null hypothesis, H0, and alternative hypothesis, HA. The null hypothesis assumes that the mean of the population is equal to a specified value. The alternative hypothesis assumes that the mean of the population is different from the specified value. 2. Calculate the test statistic. Calculate the t-statistic using the formula t equals x bar minus mu by s by square root n, where x bar is the sample mean, mu is the hypothesized population mean, s is the sample standard deviation, n is the sample size. The degree of freedom are calculated as df equals n minus 1, where n is the sample size. 3. Interpret the results. Determine the critical value of t based on the significance level, alpha, and degrees of freedom, df. Compare the value of the t-statistic with the critical value. If the value of the t-statistic is greater than the critical value, reject the null hypothesis, and conclude that there is a significant difference between the sample mean and the hypothesized population mean. If the value of the t-statistic is less than the critical value, fail to reject the null hypothesis, and conclude that there is no significant difference between the sample mean and the hypothesized population mean. Or, determine the p-value associated with the t-value using a t-distribution table or a calculator and compare the p-value with the significance level. If the p-value is less than the significance level, alpha, reject the null hypothesis. If the p-value is greater than the significance level, fail to reject the null hypothesis. Example. A researcher wants to test whether the average height of a sample of 30 male students is significantly different from the population average height of 175 centimeters. The sample has an average height of 180 centimeters and a standard deviation of 5 centimeters. To test the hypothesis that the average height of the sample is significantly different from the population average height of 175 centimeters, we can use a one-sample t-test. The null hypothesis, H0, is that the population mean is equal to 175 centimeters, while the alternative hypothesis, HA, is that the population mean is different from 175 centimeters. We can calculate the t-statistic using the formula t equals x bar minus mu by s by square root n, where x bar equals sample mean, 180 centimeters. Mu equals population mean, 175 centimeters. S equals sample standard deviation, 5 centimeters. N equals sample size, 30. T equals 180 minus 175 by 5 by square root 30 equals 5.48. The degree of freedom for this test are n. 1 equals 30 to 1 equals 29. Using a t-distribution table or calculator with 29 degrees of freedom and a significance level of 0.05, we find the critical values to be plus or minus 2.045. Since our calculated t-value, 5.48, is greater than the critical values, plus or minus 2.045, we reject the null hypothesis. This means that there is sufficient evidence to suggest that the sample mean height is significantly different from the population mean height at a significance level of 0.05. We can interpret this result as meaning that the sample of male students has an average height that is significantly greater than the population average height of 175 centimeters. Advantages of one-sample t-test. Easy to perform. One-sample t-test is simple to perform as it only requires a single sample to be analyzed. Widely used, one-sample t-test is one of the most commonly used statistical tests for making inferences about the population mean. Applicable to small sample sizes, one-sample t-test is suitable for small sample sizes, which makes it useful in fields where data collection can be challenging, such as medical research. Disadvantages of one-sample t-test. Assumes normality. One-sample t-test assumes that the population distribution is normal, which may not always be the case. Sensitive to outliers. One-sample t-test is sensitive to outliers, which can have a significant impact on the results. Limited scope. One-sample t-test can only be used to test hypotheses about the population mean. If we want to test hypotheses about other population parameters, such as the population variance or proportion, then other statistical tests need to be used. Thank you for watching. If you found this video helpful, please give us a like. Subscribe for more videos and also share with all your pharma mates. Thank you.